Hello. In this video, we are going to study mean and variance of a random variable. Let us try to understand what is the meaning of mean. So mean is numbers in a collection tending to a central value. Suppose we have 5 numbers in a collection. So we have 1, 2, 3, 4 and 5. These are the 5 numbers that we have, and we want to find mean, or we can say average of these 5 numbers. Then we calculate it by adding all these numbers, and then we divide the sum by number of numbers. So the sum will be here 15 and divide by 5. So the answer comes out to be 3. So 3 is a central value towards which all these 5 numbers are going to tend. For example, 1 and 5 are going to tend towards 3 by 2 units. 2 and 4 are going to tend towards 3 by 1 unit, and 3 towards 3 by 0 units. So 3 is a central value, and that is called the average. Now, in case of a random variable, mean of a random variable is defined differently, not in this way. So in case of random variable, mean is sum of product of values of random variable with its corresponding probabilities. For example, suppose we have a random variable x, and its different values are x1 to xn, and its corresponding probabilities are p1 to pn. Then we have to multiply each of these numbers with its corresponding probabilities, and then we add them. So the mean value of random variable x, or expected value of random variable x, or we can say it mu, is equals to x1 into p1 plus x2 into p2, and so on till xn into pn. We can write this in the form of sigma notation also, and that is sigma I equals to 1 to n xi into pi, where I varies from 1 to n. So this expression is called mean of a random variable. Let us now study variance of a random variable. So in general, variance means how far a set of numbers is spread out. Suppose we have n numbers and we calculate its average. So we would like to know how far these numbers are away from its average value. So this is called variance. Now, if we have random variable x and we would like to know its variance, then we can find it using this expression, that is variance of x is equals to sigma I equals to 1 to n xi minus mu whole square into p of xi, and I varies from 1 to n. Here xi's are the values of random variable x, and p of xi's are corresponding probabilities to xi. Now this is how we calculate variance of x. And in this expression, this sigma x square is nothing but a standard deviation, and we can find it out using this expression, that is square root of variance is standard deviation. Now, what is the difference between standard deviation and variance? In practical sense, sometimes this value is more useful and sometimes variance is more useful. So depending upon our needs, we either use standard deviation or we use variance of random variable. Now there's another way of writing variance of x, and we can find it out using again this expression only. So in this expression, we will expand this term and we get variance of x is equals to sigma I equals to 1 to n xi square minus 2 mu xi plus mu square into p of xi. Now we'll separate this out, we'll break this term individually, and we get sigma I equals to 1 to n xi square into p of xi minus, now here 2 and mu are constant numbers, so they can be taken out of summation, and we get is sigma I equals to 1 to n xi into p of xi plus, here also this mu square is a constant number, so it can be taken out from summation, and we get sigma I equals to 1 to n p of xi. Now from previous video, we have seen that this value is equals to 1, that is sum of the probabilities and a random variable is always equals to 1. So this becomes simply mu square, and we have studied earlier that this is nothing but mean value or mu. So minus 2 mu into mu becomes minus 2 mu square, and finally we define this as e of x square, that is e of square of random variable x. Now finally we get to expression this variance of x is equals to e of x square minus mu square, and we know that mu is nothing but e of x. So ultimately we get variance of x is equals to e of x square minus e of x whole square, and this is what we apply in problem solving, that is variance of x. So this was random variance of a random variable x. Let us now solve an example, and in this example we have a random variable x whose values are -1, 2, 3 and 5, and its corresponding probabilities are 1/5, 2/5, 1/5 and 1/5. Now we have to find the values of mu, variance of x and standard deviation, and we know that mu is equals to sigma xi into p of xi, and xi here is -1 and p of xi is 1/5. So mean value will be equals to -1 into 1/5 plus 2 into 3/5 plus 3 into 1/5 and finally 5 into 1/5, and from here we get 13/5. So this is the value of mean. Now we will find out variance of x, and before we find out that, first we have to find out e of x square, and we know that e of x square is equals to sigma xi square into p of xi. Here xi square will be -1 square into p of xi, that is 1/5. So -1 square into 1/5 plus 2 square into 2/5 plus 3 square into 1/5 and finally 5 square into 1/5, and we get answer as 43/5. So this is the value of ex square. Now we have to find variance of x, so we will find it using this expression, using ex square minus e of x whole square, and it comes out to be 43/5 minus 13/5 square, that is equals to 46/25. Now from here we'll find standard deviation, which is equals to variance, square root of variance of x, and we know that variance is 46/25, so its square root will be square root of 46/5. So these are the values of mu, variance of x and standard deviation for this random variable.